Hi guys, welcome to this page of the notes. Now, what we're going to do here on this page is begin to take a look now at the second objective or learning target, which is being able to put together composite functions, which is essentially going to be a function inside of another function. And I'll get to that in just a second. But what I've got with me is just something to sort of give you a visual of what's going on here. My wife actually, when she was in high school, had an opportunity on many occasions, actually a couple of occasions, to go over to Russia and do a little bit of work in an orphanage over there in Russia. And one of the more popular sort of souvenirs or trinkets to bring back from Russia with you when someone goes over to visit is what's known as sort of these Russian nesting dolls. And the way that these work is you just buy these little dolls, but the way that they work is as you take them apart, you find inside smaller and smaller dolls, right? So they just keep coming apart until you get all the way down to, actually here, let me set these down so that I don't drop them or break them. As you keep going, they just keep getting smaller and smaller, and actually surprises you as you go all the way down through here just how tiny they get, all the way down to this last small little doll. So again, these things known as Russian nesting dolls. Actually, this is a great sort of analogy to what you're going to be doing here now in this portion of the notes of Chapter 6, Section 1. Let me show you what it looks like. What we generally do when we're dealing with functions is what we ask you guys to do is to pick some domain value, some value of x. Right? We're going to call this our x. Now, what you do is you take that domain value and you plug it into a function. We'll call our first function g. And what happens is that function gives you something new. So I take some domain value of x, I put it inside of a function, and put my value of x inside of some function, and I get something new, something different. I get out a range value. And generally that's where we stop. You have then evaluated your function g for some domain value, and you've gotten out your range value. But what we're going to do here now in this section, this chapter and section, is we're going to go farther than that, right? We started with some domain value. You start with some value of x, and you plug it into a function, and you get out something new, right? Some new range value. And we're not going to stop there. We're now going to do what's known as a composite function, where I take that new range value, which I call g of x here, and we're going to put it inside of yet another function. So I take this guy and put him inside of yet another function, which I have called f of x, and I get out something else. I get out yet another range value, and this is what's known as a composite function. I've picked a domain value, which I plugged into some function, we'll call it g, and I get out that value. But I don't stop there. I then take that range value and I plug it into another function, yet another operation performed on it. And what comes out is what's known as f of g of x, right? Because I've taken that g of x, right? I've taken that x, I've plugged it into g to get g of x, and then that g of x has been plugged into f, the function f, to get me f of g of x, right? So what you're going to be doing is going a little bit further here with evaluating functions. We're not just plugging a domain value into one function, we're actually going to be substituting into a couple of functions, and this is known as composite functions. So let me slide back up and highlight a couple of things for you here as we're going through this section, things to look for. What we're going to be doing again is just a quick sort of way of thinking of this is a function inside of another function, all right? A function inside of another function. And again, the way that this is going to work, in most cases, this property of composite functions is not commutative. What that means is that putting g of x inside of f of x is not equal to putting f of x inside of g of x. They're actually going to be different. Now, sometimes they come out to be the same. Sometimes that's a very special case, and we'll actually use that to our advantage here in a little bit, I believe, in the next section. But generally, they're not the same. All right, so you want to be really careful. Their order is very, very important. That's the point I make here. The order is very important. And then the last thing I want to highlight for you before we go and take a look at a couple of examples is this. It's possible that the composition of two functions may not exist, in which case we would just simply write our answer as undefined, or DNE does not exist. And so again, what we're going to be doing here with these composite functions is essentially putting a function inside of another function. So head on over to the next page of the notes, kind of keep that idea of the Russian nesting dolls in mind as we run through the next few example problems, and I'll meet you over there.